how we how we simulated the model. So you just watch. Maybe you get confused. We have developed so many models, sub-models. So I will just close it. So first we created one new project file. So for that we go to file, new, then this time I will give one name like Nehari 2. Then I will have to provide the location where I will create the project. कोई कर रहा है क्या? करने की जरूरत नहीं है, बस आप देख लीजिए. And just then create. Now the empty project has been created. So next process is we have to take the TEM for watershed delineation. To bring the terrain data to this HMS model, what we have to do, we will go to GIS, component, and then terrain data manager. You click terrain data manager, it will ask for the name of the terrain. I will put it as terrain 1. Next, then file name, where I have saved my terrain data. This is the digital elevation model data. So elevation.tif, select it. Vertical units I will keep as meter and finish. Close it. Now terrain data is visible in the watershed explorer. You expand it. This is the name I have given for the terrain data. Once you click it, you can see the vertical units is metered and the location of the path of the file where the DEM is being saved. Now the terrain data is not visible in the Windows, this map interface. So how to bring this to this map interface? For that we have to create the basin model. So to create the basin model, we will go to components, then basin model manager, create one new basin. I will keep it as basin 1, create, done. Now I have created this basin 1 basin model. Once I click it, then in the component editor we can see under terrain data, now nothing is selected. I will now select this DEM that has been now created. So terrain 1, so still it's not showing. We have to assign the, it's showing but we haven't yet assigned the coordinate system. We have to assign the coordinate system. So click on basin 1, GIS, coordinate system. I will go to predefined. Then our location is UTM zone 46. So universal transverse marketer 46 zone. I think Meghalaya is also 46. 46 hemisphere is your northern hemisphere, and datum I will select as WGS 84, World Geographic System. Select, set it and close. So now the DEM is visible in the map interface. Just एक सेकंड में मीनाक्षी को देती हूँ. क्या बोलोगे उनको? हाँ हाँ बताओ. चेक करो आ जाओ. I I will just zoom it a bit. Now the DM data is visible. Now once we have imported this digital elevation model, the next step is to delineate the watershed. So to delineate the watershed, we will go to GIS. The first option is your pre-process the sinks. This is the fill sink operation. I will click here. So now sink fill operation is done. The next is pre-process drainage. So pre-process drainage means it will create the flow direction map as well as the flow accumulation map. So click on pre-process drainage. Okay, so pre-process drainage. So we have determined the flow direction and flow accumulation. Now the next is our identify streams. So click identify streams. Now it will ask for your threshold value. So what is this threshold value means? If I give a larger value, then I will get less number of streams. So in that case, you may not get multiple sub-basins, only one basin. So we provided 150 for this particular project. So I will provide 150. You can try with different values also. Then if I put let 30, 20, then 300, then what will be the difference? So I will put 150. Okay. Now if I right click map layers, so these are the different layers that have been generated. I will just uncheck flow accumulation, flow direction, sink locations, and the original terrain. So I just need this identify streams layer. Now I have to delineate. To delineate the watershed, I need to give the outlet of that particular stream. So go to GIS. The next is your breakpoint manager. Once you click here, it will ask to import the outlet. Otherwise, yesterday I told you this is the option. If you click here, then you can click on any stream to define the outlet. So now I already know my outlet point, so I will import outlet. So it is saved as breakpoint. Open, import. So now it has been imported. Now next is our GIS. Then delineate the elements. Here delineate elements means subbasin, reaches, all these things. So delineate the elements, then it will ask for the name. I can name the subbasin prefix like S, sub, like this, but I will keep it as default. And then junction insert, I will say yes, then delineate. So this basin has been delineated with five different sub basins, 2 reaches and 2 junctions. So this is how I have delineated the watershed. Now once I delineated the watershed, the next step is we have for the hydrological process, surface water hydrology, there are different processes as part of water cycle. So we have to define different methods for each of the processes. So there are different methods available like canopy, surface loss. So we have considered only loss and transform method for the subbasin and the routing method for the reaches. So I will click on loss. Now initial and constant is being selected by default. I will change it to SCS curve number. Change it. Then go to again parameters. Next is your transform. Transform, we will select SCS unit hydrograph. Change it. SCS unit hydrograph. Change. And then the reach parameter. Sorry, for base flow it is selected as recession. Now I don't want any base flow data. So change the method to none. Change it. And then go to routing. Lag method is selected by default. I will change it to Muskingum. So Muskingum, then change it. Okay. Now, when we select any subbasin, in the component editor, we can see the different methods. For loss method, SCS curve number is now added. For transform method, SCS unit hydrograph and base flow method, none. So this has been now defined. The methods have been defined. Now we have to give the values, different parameter values for each method. Like for loss method, now there is no value. So what we will do, I will select the basin as a whole. I will go to parameter, loss, SCS curve number. I will populate this table. So as per the formula, CN number is given. I have calculated the initial abstraction. So I will put those values. These are the curve number values. And these are the initial abstraction. Now apply it and then close. So I have defined the curve number parameters. Now the next is your transform SCS unit hydrograph. Here we have to provide the lag time. So I have calculated the lag time in minutes. Apply and close. So now for the subbasin, for the loss, I have provided the values, and for transform, I have provided the lag time. Then I will go to basin again, parameter, then routing, masking gum. So with the help of the formula, we have determined the values of masking gum K for reach 1 it is 2.6 and for reach 2 it is 3.8. For reach 2 it is 3.8 and reach 1 2.6. And masking gum X values we have considered the constant 0.25 for a simulation. Apply it and close. Now we have defined all the parameters, right? For reach, this is the masking gum, routing, then these values are populated. So now now basin model creation is complete with this. Next we will have to create the meteorological model. So to create the meteorological model, again we go to components, meteorologic model manager, create a new meteorologic model. I will keep the name as mat1, create and close it. Now this mat1 has been created. So when we click on the mat1, below there are different options. I will skip but the evapotranspiration. So evapotranspiration, there are different methods, there are different values you can give. The easiest one, monthly average. I am taking the monthly average option. Click yes. Okay. Done. Now, for each sub-basin, when I expand it, sorry. Basin model, then at one monthly. Now for basins, it is written as no. I will give yes. Options is okay. Now, say for each sub-basin, the monthly average option is available. Now, for each sub-basin, I will provide the potential evapotranspiration values. So, for So now for each subbasin, the monthly average value, we have to put the potential evapotranspiration value. For subbasin 1, monthly average value is so for both subbasin 1 and 2, these are the values. And for subbasin 3, 4 and 5, I am considering potential evapotranspiration. And the coefficient, I considered a constant. What happened? 1.1. I will just copy this. So now I have given the potential evapotranspiration values for each of the subbasin. So next is we have to we have to create the gauges for the rainfall data. So for that I will go to components, then time series data manager. So there are options. I will click on the precipitation gauges, new, create. Gauge 1 has been created. Then again click on new. There will be another gauge create, and then gauge 3. So create. Now under the time series data, precipitation gauges, 3 gauges has been created. Now expand it. You can see this one. Click here. So there are options. You have to give the time series, then time window, table and graph. So time series, so unit is in millimeter. Your time interval is, these are daily rainfall. So I will keep as 1 day. Now the time window for rainfall, it was 1st January 2015 to I think 31st December 2019. Now I have to give the values in this table. Say for gauge 1, once you put the values, you can see the hydrograph. Then for gauge 2 again, So now we have incorporated all the values of gauge 1, 2 and 3. Now the next step is we have to link those gauges to the respective subbasins. For that, I will click the meteorological model. Then the first one is your specified hydrograph. If you click here, for each subbasin, the gauging option is there. So for subbasin 1, 2 and 3, I will take the gauge 3. Then gauge 2 and gauge 1. So with this, the creation of the meteorological model is completed. Then the third and the final model, submodel we need is the control specification. So go to components and control specification manager. Create one new control specification manager. So when you expand it under control 1, so we have to तक किया है. Time interval, this time this is the computational time interval. I will keep it as 15 minutes. So done. Save it. So now basin model, meteorological model and control specification models have been created. Now finally we have to run the model. To run the model, I will create one simulation. So go to compute, create compute, then simulation run. So I will give the name as run 1. Go to next. So it will ask for the basin. So I have created only one basin model. So basin 1. The next, the meteorological model, MET 1. And then finally the control specification file, that is control 1. And then finish. So now when I go to this compute tab, this simulation run 1 file has been generated. So now to run the model, you click on run and then this is the option compute all elements. You click here, then the process is done. Oh, it's been run, but one thing I forgot to do under the meteorological model. This is the option replace missing abort compute. So I will set it to default. If it find any missing data in the rainfall data, still it will put the default value. Now I will compute it again. Done. Now to see the results, you go to this results tab, simulation run 1, you click here, then all the options to view your results is there. Global summary, calibration summary, subbasin 1, all these things. And what are the different options I mentioned? You can check the results from this tab, or else for each subbasin also just go there, right click, view results. So options are there. Otherwise you can go directly here, graph, global summary, elementary graph, all these things, or else results is also available in the menu tab. So these are the options for viewing different results. And for spatial visualization, what we have to do, we go to compute. This is run 1. Now the spatial results option is selected as no. I will click yes. Then spatial interval, it can be anything, but I will put say 3 hours now. And then run the model again. Close it. Now here, this is the animation toolbar. You select anything. Okay. Now you can swipe this toolbar for visualization, spatial visualization. Okay. So this is all the overview of the entire HEC HMS model, how to simulate the HEC HMS model. So now you open your model, whatever you have created. So now I will check whether our simulated runoff is closer to our observed runoff or not. For that, see again for rainfall data input, we created the time series data. Now we will again have to create one time series data for the observed discharge. So go to your components, time series data manager, and this time instead of precipitation gauges, I will select discharge gauge. New, create. So now under time series data, we can see another gauge, that is discharge gauge is created. Fine. In your data folder, I have given you one Excel file as flow_outlet. So under the gauge 1, under discharge gauges, gauge 1, again we have to fill up these values. So this time observed discharge, I will take the values from 2015 to 2017 because for that period I am calibrating the model. So here for January 2015 to 31st December 2017, time series, this is again daily data, cubic meter per second unit. It's okay. Then table, I will put the values from 2015 to 2017. Precipitation पूरा है वो बस कैलिब्रेशन में सुनिए हाँ हाँ So this observed value is at the outlet point. So now we have to link this discharge to our outlet. So outlet is designated as sink here. So when I click on the sink, you can see the component editor. Here the observed flow, now it is selected as none. So I will select it as gauge 1. If you are giving the name as gauge 1, then gauge 1, otherwise whatever name. Done? When you click on sink, go to the options, select the observed flow as gauge 1 or whatever gauge name you have given for the discharge data. So now this observed data is linked to the outlet. After that, I will run the simulation once again. Go to compute, run and run the simulation. Are you following? So now you go to results, run one and go to sync. Now you check the summary table. So in summary table, for calibration process, Nash Sutcliffe efficiency it is showing 0.395. First you see the graph, expand it. So in the graph you see the black line is showing the observed discharge that we have incorporated just now, and the blue is your simulated discharge. The model has been simulated. So I can say, if I zoom it, see this is the dotted black one is your observed, and the model simulated sometime, like somewhere it is overestimating. Okay. Then our goal will be to bring this peak closer to the observed one. So now another option to check the accuracy is this, the summary table. So in the summary table, this is the Nash-Sutcliffe efficiency. So Nash-Sutcliffe efficiency is one of the statistics. One of the statistics that can, on the basis of which we can say whether the simulated model is satisfactory, very good or good. Whatever the ranges is there. If it is closer to 1, then this is a very good model. But now this is 0.395. This is not acceptable. So we can try to bring it closer to say for 0.7, 0.6 up to that. So that is the process of calibration. So calibration is an iterative process. We have to now change different parameters. We will play with those parameters and check whether the calibrated result is हाँ हाँ कल जो दिया था मैंने हाँ किसी का सबका इतना आ रहा है या अलग अलग आ रहा है आपका माइनस आ रहा है बहुत ही खराब ठीक है So it's going to be that after that, show you how to calculation. So there are manual options, manual calculation and automatic calculation. So we will after.